Hi friends, in this video, we will understand in detail how throughput plays a vital role in deciding the decoding capacity of SATATYA devices. SATATYA devices are classified into three categories based on the total number of cameras that can be connected with them. First, 8-channel, second, 24-channel, and third, 64-channel. Throughputs of these devices are approximately 50 Mbps for 8-channel, 144 Mbps for 24-channel, 256 Mbps for SATATYA NVR64S, and 384 Mbps for SATATYA NVR64P. We will take the example of SATATYA NVR8S. Also, we will presume two conditions. First, user is watching the cameras in TV monitor and PC. And second, recording of all cameras is on. Throughput of any SATATYA device can be divided into three further categories. First, downstream, second, stream limit, and third, upstream. Let us understand about downstream. Downstream is the stream transferred from the IP camera to SATATYA device. Throughput of SATATYA NVR8S is approximately 50 Mbps. In the broadest definition, downstream can be easily calculated by multiplying the number of maximum cameras that can be connected with the NVR with the bitrate of each camera. In our case, the number of maximum cameras of SATATYA NVR8S is 8. The user can watch the cameras in mainstream or substream. Bitrate of each camera recommended by Matrix is 2 Mbps for mainstream and 1 Mbps for substream. Considering the user watches all cameras in mainstream, downstream is 8 into 2, that is 16 Mbps. As the recording of all cameras is on, the downstream in this case will be 16 Mbps, assuming that the recording stream is mainstream, even if no user is watching any camera. Bitrate of each camera can be kept high. However, it is recommended not to exceed this limit for better performance of the device. This completes the understanding about downstream. Let us understand about stream limit. Stream limit is the limit of SATATYA device to take in or give out the stream of cameras. In stream limit is the maximum number of streams of cameras that the device can take. It is equal to the total number of cameras that the device supports. In our example of SATATYA NVR8S, in-stream limit is 8. Outstream limit is the maximum number of streams of cameras that the device can give. It is equal to 3 times the total number of cameras that the device supports. In our example of SATATYA NVR8S, outstream limit is 8 into 3, that is 24. The stream limit can be seen in device status option followed by system and more. Note that this is the combination of live and network streams. Live streams are the ones projected on the monitor connected with the device. Network streams are the ones projected on users' PCs through SATATYA device client. This completes the understanding about stream limit. Let us understand about upstream. Upstream is the amount of bandwidth allocated to a user who is logged in to SATATYA device client. Consider a scenario in which user 1 is watching all 8 cameras connected with SATATYA NVR8S at the same time in TV monitor. Also, it is considered that optimized bandwidth flag is not enabled at this time, resulting in deliverance of only mainstream of all cameras irrespective of the layout set. Bitrate of each camera connected is 2 Mbps. Now downstream in this case is 16 Mbps and upstream is 0 Mbps. Also, outstream limit is 8. If user 2 logs in and watches all 8 cameras simultaneously in his PC, the device will allocate 16 Mbps to that user. Now downstream in this case is 16 Mbps and upstream is 16 Mbps. Also, outstream limit is 16. If user 3 watches all 8 cameras connected with SATATYA NVR8S at the same time in his PC, the device will allocate another 16 Mbps to that user. So downstream will be 16 Mbps and upstream will be 32 Mbps. Also, outstream limit is 24. Thus, one more user can log in and watch just one camera in mainstream. If this user tries to watch one more camera, the device may drop frames or live view of cameras can get stuck for a while. This is solely because the upstream of the device is reaching its limit. To overcome the limitation of upstream, optimized bandwidth feature is used. Optimized bandwidth flag will enable automatic switching between main and substream of IP cameras. All IP cameras have 2 video streams, namely mainstream and substream. Bitrate is generally kept high for mainstream and low for substream. In the previous scenario, the assumed bitrate 2 Mbps was for mainstream. Let us assume the bitrate for substream as 1 Mbps, that is half the value of mainstream. Also assume that optimized bandwidth flag is checked. When user 1 watches all 8 cameras at the same time in TV monitor, downstream in this case is 16 plus 8, that is 24 Mbps, but upstream is 0 Mbps. First 16 is because of the recording streams and the second 8 because of the live streams. Also, outstream limit is 8. When user 2 watches all 8 cameras at the same time in his PC, the device will allocate another 8 Mbps to that user. So downstream in this case is again 24 Mbps, but upstream is 8 Mbps. Downstream will remain unchanged as now the device is transferring the stream to the user. Also, outstream limit is 16. When user 3 watches all 8 cameras at the same time, the device will allocate another 8 Mbps to that user. So downstream in this case is again 24 Mbps, but upstream is 16 Mbps. Also, outstream limit is 24. Now, as the outstream limit is reached, the device will not be able to stream any more cameras. If the user starts the stream anyway, maximum stream limit reached error will be displayed. To overcome this, the current users will have to stop watching certain number of cameras. This completes all the parameters. Thank you for watching this video. For further queries, please contact Matrix Technical Support Team.